They do, but I'm asking you to verify it. Okay. We've talked about the general solution to the complementary equation. Let's get back to the original Diophantine equation, and that's AX plus BY equals greatest common divisor of A and B. If we have a particular solution, let's say xy equals x naught y naught, if we have a particular solution to the original Diophantine equation, and if xy equals uv is a solution to the complementary equation, then xy equals x naught y naught plus uv is a particular solution of the Diophantine equation. Let's go over what I just said. If we have a particular solution, x naught y naught, to the original Diophantine equation, and a solution to the complementary equation, the sum of these two things is also a particular solution to the original Diophantine equation. That thing right there. So the sum of a particular solution and a complementary solution gives us another particular solution. And here's why. If xy equals x naught y naught is a particular solution of this equation, the original equation, that means that when we plug in x naught y naught for x and y, we get this thing. Specifically, it means ax naught plus by naught is the right-hand side of the equation, what it's supposed to be. Now, let's consider uv. If x equal u, y equal v is a solution to the complementary equation, ax plus by equals 0, then a times u plus b times v is 0. That's what it means for this thing to be a solution to that equation. Now, consider what happens when we compute the sum of the particular solution and the complementary solution. We have xy equals particular solution plus complementary solution. And if we add these things component-wise, we get x naught plus u for the x component, and we get y naught plus v for the y component. So, the sum of these two things is x equal x naught plus u, y equals y naught plus v. And what happens when we plug in these x and y values into ax plus by? We get ax naught plus u plus by naught plus v, and we distribute the a inside the parentheses, distribute the b inside the parentheses. So we get ax naught au, we get by naught bv, and then we group them differently. We take the ax naught and the by naught and group them together. And we take the au and the bv and group them together. But wait a minute. Ax naught plus by naught, that's the greatest common divisor of AB because this is a solution to the original equation. And au plus bv, that's equal to 0. So we add greatest common divisor of A, B, and 0 together, we get greatest common divisor of A and B. So in other words, when we plug in x naught plus u, y naught plus b, we get greatest common divisor of AB. And again, what are these two things? X naught plus u, y naught plus b. They're the sum of a particular and complementary solution. So, the sum of a particular solution and a complementary solution is also a particular solution to the original Diophantine equation. Now here's our main result. The general solution of the original Diophantine equation is given by this: a particular solution, any particular solution, x naught, y naught, plus the general complementary solution. That's the main result. For example, consider again the equation 945x plus 200y equals the greatest common divisor of 945 and 200. ax plus by, greatest common divisor of a and b. Well, we found the greatest common divisor of those two things. It's 5. So we're really finding the general solution for the equation 945x plus 200y equals 5. And remember from what we did earlier, x naught, y naught equals negative 1152 is a particular solution to the Diophantine equation. And the corresponding general complementary solution, xy equals b over dt, negative a over dt, for all integer values of t. Well, let's see. D, the greatest common divisor, is 5. B is 200. A is 945. So when we simplify it, xy equals 40t minus 189t for all integer values of t is the corresponding general complementary solution. So the general solution of the original Diophantine equation, 945x plus 200y equals 5, is given by xy equals, what's this? A particular solution. And what's this? The general complementary solution. Now, if we add these two things component-wise, we get negative 11 plus 40t for our x-coordinate, and 52 plus negative 189t for our y-component. And this will generate all solutions of the original Diophantine equation. So this is our solution. xy equals negative 11 plus 40t, 52 minus 189t, for all integer values of t. And here's a sample of our solutions. If we plug in negative 2 for t, negative 11 plus 40 times negative 2, 50 minus 189 times negative 2, that we get the solution negative 91, 430, which really is a solution. If we take negative 1 and plug it in for t, we get negative 11 plus 40 times negative 1. And y equals 52 minus 189 times negative 1. That gives us xy equals negative 51, and y equals 241, and so forth. I'd encourage you to check some of these with a calculator just to convince yourselves that they really do work out this way. That's the end of our lecture number 1. It's good to have you back again. I'll be corresponding with you about some homework exercises very soon.